So one of our concerns around Lake Champlain showing signs of eutrophication is that it's reached some kind of threshold or ecological limit.
In some places where those algae blooms are just persistent, summer after summer looking the same, we do worry that perhaps we've crossed a threshold of condition in the lake where it's going to be very, very difficult to bring the lake back.
It's hard once water is contaminated, fresh water is contaminated, to purify it again. It's very difficult to take all of those toxins or contaminants out. So for instance, with phosphorus, getting phosphorus out of a lake ecosystem is difficult. It settles in the sediment, and it's very difficult unless you were to dredge that sediment to take that phosphorus out.
St. Albans Bay might be an example of that. We know that there's a lot of phosphorus residing in the sediments. We know there's a small watershed. We know that the circulation is working against us in that bay. And so it's going to be difficult to solve the problem there. And we'll be farther ahead if we can prevent other lake segments from crossing that threshold into a different condition.
Different ecosystems have different ecological limits and thresholds. And beyond a certain stressor or threshold, those ecosystems may reach a tipping point.
We've got lots and lots of eroding stream banks throughout the basin, and the sediment that they send down to the lake gives an advantage to blue-green algae because they can float at the surface and use light right at the surface, where other algae that stay down in the water can't get enough light with the sediment that's in the water.
If there's a whole lot of nutrient that comes into the system, a big stressor in that ecosystem, you could tip all the way. So there are real thresholds that when we cross them in ecosystems, when water systems in particular, it's very hard to right those systems again.